And I'm also told that we have a caller. Hello?
Hello.
Hi.
How you guys doing?
Good, how are you?
Pretty good. So I need some math help today.
Oh, okay, I can help you. What's your question?
So I have to simplify radicals, and I don't know how.
Okay.
Awesome.
Do you have examples of some problems that you might have been given?
Yeah. Looks like square root of 80, maybe is what this is.
Okay.
And 12 and 20.
Okay, and you're saying square root of 12 and square root of 20?
Yeah.
Okay. So awesome. Not too complicated, but so what if I gave you, let's say I gave you square root of 25? What would that be?
5.
5. And so what we're thinking of is, let me think, kind of show you this idea, is that a square root and a square, they're inverse operations of each other. They undo each other. So if you thought about 25 as 5 squared, you can kind of think of this as this square root is undoing the square of that 5, and we're just left with 5.
Okay.
So using that same concept, so I used a number that is easily simplifiable to help us figure that out, or use the same concept, but we're going to look at 80 right now in the same kind of idea. So thinking of 25, the way I got 5 squared is I just thought about what are the prime factors of 25. So breaking it down, what multiplies to equal it? 3 times 5, so 5 squared.
Right.
So we're going to do the same thing with 80. So let's break that down. We're going to do a little factor tree. What multiplies to give you 80?
Well, I guess the first one will be 1 and 80.
1 and 80, good. And let's not include 1, just because we could go on forever with those ones. 1 times 1 times 1 times 1 times 1 times 80. Does it make sense? So we'll skip 1, but what would be another one?
2 and 40.
2 and 40, good. So 2 is prime, so we'll kind of quit there with the 20, but let's continue to break down the 40.
So 2 and 20?
Sure, 2 and 20. And again, 2 is prime, so we'll continue with the 20 and not the 2. So what about 20? Let's break that down.
2 and 10.
2 and 10, and same idea, 2 is prime, so let's go with our 10.
All right, and 2 and 5?
2 and 5. So what we could maybe say is that instead of writing square root of 80, we could call it 2 times 2 times 2 times 2 times 5, right?
Oh, okay.
Does that make sense?
Yeah.
So 2 times 2 times 2 times 2 times 5. And then what I want to think of is, because of this concept, this idea that a square and a square root undo each other, it's kind of like an opposite effect, an inverse operation effect. I want to take any pairs of factors that I have that I can maybe write as something squared. So let's go back. We'll maybe call this 2 squared times 2 squared times 5.
Oh, okay.
Does that make sense?
Yeah, it does.
Okay, so let me erase some of this so we have some room here. Okay. And then as I kind of mentioned before, the square root undoes the square here. So it's going to undo the square on 2 of our numbers, both of those 2's, but it won't undo anything on that 5. So what will happen is that these 2's can move to the outside of our radical, because the square root and the square, they undo each other. So on the outside of our radical, we'd say we have now 2 2's. And this 5, because he doesn't have a square, it cannot be undone with the square root. So we'll just leave him underneath our square root, and I'll make my radical sign a little shorter. Does that make sense?
It does, yeah.
Okay, and then just kind of simplifying that further, the 2 times 2 we can simplify a little bit more. We would just say that's 4 times the square root of 5. And that's our kind of final bit for simplifying them.
Okay, cool.
So what we're looking for is any perfect square factors that go into our original number.
Gotcha.
So we'll do 12 real quick,
Okay.
because 12 is a small number. So let's see, how could we break down 12?
Next one would be 2 and 6.
So 2 times 6, so 2's prime. All right, go with the 6.
And 2 and 3.
2 and 3. Okay, so we'll rewrite the radical of 12 as 2 times 2 times 3. And then again, we're looking for those pairs. So do you see any pairs?
Yeah, the 2s.
The 2's. So we'll call that 2 squared times 3. So then what will come out of the radical sign?
The 2 or just the 2 actually.
Just the 2, you got it, exactly. So we'll just take that base out because the squared and the square root undo each other. And then the 3 doesn't have a pair, so he's going to stay under the radical sign. So 2 times the square root of 3.
Okay, cool.
So relatively easy process. That'll work too once you start doing radicals with cube root, fourth root, fifth root. That concept will kind of carry through to it, which is one reason why this is a good method, because it will work for all. As you start getting more complicated in your algebra class, you could use that for other types of problems too.
Awesome, thank you.
You're very welcome. Hopefully that helped.
It definitely did.
Oh, wait, do you want to, by any chance, guess the trivia question?
Sure, yeah.
Do you know what our trivia question is?
I do actually.
Oh, okay. So what is your guess?
Let's see. Did she accidentally hear them on the radio, maybe?
Kind of. I don't know if I can give you that. Do you think that's
Where
close
did
enough?
she hear the radio?
Yeah, where was her radio?
I'm gonna say it in the car.
That was a really good guess.
A great guess. There are radios in cars, no doubt, but that is not quite the answer to this question.
Not quite. I don't think it's close enough that we can give it to you, but stay and watch the end of the show so you can get the answer.
Definitely.
I think you'll find it interesting.
Okay, cool.
All right,
Yeah.
thanks for calling.
Thank you.
Subscribe!
Come on, push the button.
You know you want to.
Do it.